one, introduction to robotics, and particularly we will be focusing on the first part of it to state the significance of the industrial robot in modern manufacturing industries. So I will start with this statement. It holds good for any time. I hope so. The robotics is a technology with a future, and it's a technology for the future. Hereafter, another 5 years or 10 years, even a robot could be placed in our home. We are going to interact with the robots at different places. It could be for malls, it could be for shops, or it could be in sometimes we are going to interact with a robot in our home. So there is some possibilities are there. There are more scopes for development on the robotics in this field. In this section, I will try to present you the how well it is progressing, what is the level of evolution has been taking place, and where we are going to place ourselves into this development part. And there is an surely there is a scope for building our skill sets in different domains of our interest, and we can proceed further. I'm sure that the robotics has a major requirement from the mechanical engineers because they will be moving the objects. They will be interacting with the objects in a physical in nature, where that needs been uh, taught to that robot. So which requires some kind of programming, some kind of electrical aspect may be required. We are exposed to we are supposed to be exposed to some kind of electrical concepts and the electronic concepts, but we will be driving this total scenario, particularly for manufacturing is concerned. As you can see that we are moving towards our industry 4.0. We are looking for the digital revolution and digital transformation, which will be helpful for us to change we need to build a new environment on the manufacture. We have a great potentiality in terms of the human resources, as well as there is a scope for improvement on our manufacturing sector, where we can utilize our robots in much better form. So as a country, we are growing. Again, the rate of growth is going to be we need to channelize ourselves and to move as per the requirement of this dynamic environment. So one of the possibility is going to be getting into that field of robotics. It is not only for the manufacturing, but also in the service sectors as well. So some questions will be there. If the increase in the robots, does it make that unemployment growth will be higher? Probably of our existing skill sets, but we are supposed to have a new opening for the new skill sets because of this new opening on the robotics, where as engineers we can play a major role. Then that of performing as uh, hands-on, it's a more of our intellectual way of doing it, and also in the value addition part of it, and not merely a repetitive and dangerous and dirty environment. Instead of working in this kind of environment, we will be working on a much better form and value addition part of it. So with that, I will start this session with an introduction to a robo, and it's also the history of the robo itself in a different form. சொல்லப்போனால் ஒரு ஃபிக்ஷன் ஸ்டோரின்னு சொல்லுவோம்ல, ஒரு கற்பனை கதைகள். அந்த இதில் தான் ஃபர்ஸ்ட் ஸ்டார்ட் ஆச்சு. இட்ஸ் when we are started by 1920 by the Carl Carter of a science fiction story of where imaginary machines will be ruling the human. So it's considered to be a drama, but it has been converted into a reality. That's what the engineering is all about. Whatever it has been dream of, that could be converted into a reality. So after 40 years of his play, it has been made into a manufacturing sector as a robo, not with a more of an intellectual, but it does its work replacing poetic work of a robo. Poetic work of the human. So the robo has been one of the machines which will be support us or assist us or augmenting us to make it as our work in much better form. So usually the robotics are said to be a branch of technology that deals with the design, construction, operation, and application of robots. So it's considered to be a major domain of where um, expertise is required for in this scenario. So with the continuation of this one, another writer of named Isaac Asimov has declared some kind of three rules or three laws of robotics, which makes it the how the robot has to be. It's whereas the Kalpak fiction story play will be makes us to it rules human. So in order to have that, how we are going to dominating or how the robot supposed to behave with a human, he has declared some kind of three kinds of laws. A robot may not injure a human being or through inaction allow a human being to come to harm. Or in any case, the robot should not harm a human being. And robot has to obey the orders of the human beings, except where such orders would conflict with the first law. When you're saying the first law says that the robot should not harm the human. The human should not use a robot to harm the other person. The second law said. Third, the robot must protect its own existence as long as the protection does not conflict with the first or second law. In the sense, the robot has to protect itself and also not to harm the others. So fundamentally, a robot is supposed to work with us, but not harming us, or sometimes it's not harm itself. So that the total environment is supposed to be in much better world. So with the thought of this aspect, the robot is progressing. The robot in the sense the robotics technology is progressing. So with that, there are plenty of robots has been deployed in the manufacturing. And this too, it's considered to be a programmable machine. I hope that you're all in the 5th and 7th semester. You have been undergone the courses on manufacturing automation kind of things, where the CNC machines, ANC and CNC machines, where the machines will be coded with an NC codes or the programming, and it will be made into work for our machining purpose. Uh, can anyone suggest me that what is the need for using a CNC in our uh, in manufacturing? Okay, particularly for automation is going to be poor. What's the need for automation? That's an inherent question. Why we need to use a CNC instead of our traditional one? Okay, good, very good. Good surface finish, accuracy, exactly. That is the manpower, speed up the process, accurate, and also we need to meet up the demand of the market and the requirement. So which requires we need to trade off between the accuracy, quality, and the time. And it's supposed to have a better quality product with a cost-effective way. That's why the market requires exactly. So it's going to be more cost-effective solutions. We are expecting cost-effective solutions in a shorter time. So that will be avoids some kind of inaccuracies that happens on where the manual intervention. However, the CNC cannot replace the human, but the CNC may require the programmers for the NC codes. So it's a more of the perception in which how we are viewing this and how well we are going to develop the skill set within us. That makes it the things. Very good. Thanks for your responses. You are on the right path, and we need to work on much better than this one. So CNC is a standalone machine alone. It will be does its processing. What about your handling purposes? In the sense, நம்மளே படிச்சிருப்போம் material handling systems, material handling devices அப்படிலாம் படிச்சிருப்போம். So what's the material handling is part? What's the purpose of the material handling devices? Why not use a human? Can anyone just respond to it if possible? ஏன் நம்ம வந்து ஹியூமனை யூஸ் பண்ணிடலாமே எல்லாமே ஏன் வந்து எக்ஸாக்ட்லி First consideration is the safety. Excellent. And it is an fatigue also. For the human takes on more time. Safety is required. That's the chances of human error. Excellent. So if you are looking at this concept, we will be on the right place. And how well we are going to convert this into a useful and much better places. As engineers, we are looking into where the constraints will be there in terms of time, cost, and our resources. How effectively we are going to manage all the three components so that uh, okay. So with that, we are going to have an industrial robot that are automated, programmable, and capable of movement over toward the axis for executing various applications in manufacturing. So the robots could be placed in a different formats. However, this course is focusing on manufacturing, prior to the simulation part. Okay, Robotic Industries Association, this can be a very renowned institute on the area of robotics. It says that we are more focusing towards our industrial robot, in the sense the robots that are used for the industry requirements. An industrial robot is a reprogrammable, multifunctional manipulator designed to move materials, parts, tools, or special devices through a variable programmed motions for the performance of a variety of tasks. So this statement we need to recollect as much as possible so that are we justifying for it? Very simple thing is this first statement is a reprogrammable. So programmable is okay. We are going to do a reprogram. In the sense, it could be used for multiple times and multiple uh, different kinds of programs could be enabled. The second part is multifunctional. In the sense, it can does different functions. It could do a pick and place, or it could do a welding, or any kind of an activities. The task we are looking for, and it could be used on. And it is particularly designed to move the materials, parts, tools, and special devices. In the sense, it's a morely a material handling system, considered to be a material handling system, but it has an precision and accuracy will be much better than a human. So how well we are going to use it, but then particularly concentrating on the safety is a fundamental underlying principle through the variable program the motions. So we require different motions to be executed for each of the parts or the task to be performed. So for the performance of a variety of tasks. So when you're reading this one, we have a different insights will be there and try to take it as a keywords, the reprogrammable, multifunctional, to move what? It's a material parts, tools and special devices. How it can be? It's through a variable program motions. What is the purpose of doing it? To ensure the performance of the variety of the task. So in industrial robot is a device or a manipulator, a multiple functional manipulator. That too, reprogrammable multifunctional manipulator designed to move the materials, parts, tools, and special devices through the variable programming motion for the performance of variety of tasks. This will be a more sensible statement and it has an more of an inherent meaning in it. As we go through it, we find out how this statement is a more effect here. The second part of definition. So there are so much of definitions has been provided. I have preferred to take it as these two from another part of it. And from the ISO in terms of International Organization for Standardization. Is an automatically controlled reprogrammable multipurpose manipulator, programmable in three or more axes, which can either be fixed in place or in mobile for use of industrial automation application. So very simple thing is it is how it has been controlled that has been provided here. It's automatically controlled. The reprogrammable multipurpose already done. And it has been specifying that at least three or more axes could be need or considered to be an industrial robot, which can either fix a place. In the sense, some of the robots will be has a base will be fixed. Some of the robots will be keeps on moving. It could move on the linear slide, or it'll be a wheeled path. It could move based on the requirement of the application. So fundamentally, it is for industrial automation. So yeah, it has different kinds of major things: a manipulator, controller, and communication interfaces. When you're saying the manipulator is a more of a rigid bodied concept, we can say that it's a more of a links, a physical structure will be there, including the actuator, will be considered to be a manipulator. The manipulator will be controlled by some kind of a system or controller, and that we have needs some kind of a communication between them. That's the communication interfaces. It could be of our hardware as well as the software. Very simple examples will be of whatever we have in our laptop or mobile phones. We are having a physical object and the processor inside, and there has an interfaces like your USB interfaces or HDMI interface. If you are considering in terms of your laptop is concerned, you have a different kinds of interfaces. That too, inside there is a software is available for getting the data and processing it. That's a way we have to structure this robot. So in this case, okay, I can start up the presentation. Yes. Okay. I hope that I have convinced what a robot will be look like. We are taught. It's a very simple thing. It's a programmable machine that imitates the actions or appearance of an intelligent creature, particularly human. In the sense, wherever human has been employed, we are going to use some kind of a devices. That too is an automated device. That's called robot. Because the human find very difficult some places like welding or carrying in heavy objects. There we need some kind of support from the machines. That's a programmable machine. So in order to qualify a robot, so some four major elements has been considered. This is going to be a very simplest version of it. Again, there's a major list is there. I prefer to have these four things. One thing is sensing and the perception. Very simple thing is how we'll get the information from the surroundings. If you want to understand, நம்ம ரோபோ பத்தி நல்லா தெரிஞ்சுக்கணும்னு நீங்க நினைச்சீங்கன்னா கனெக்ட் யுவர் ரோபோ யுவர் செல்ஃப். நம்ம எப்படி பிஹேவ் பண்றோம் சென்சிங் அப்படின்றப்ப we have started receiving this information visually as well as by hear, is it not? ஸோ அதுலேருந்து இன்ஃபர்மேஷன் கேதர் பண்ணி நமக்குள்ளே ப்ராசஸ் பண்ணுறோம். பண்ணிட்டு ஒரு இன்ஃபரன்ஸ் கிடைக்கும். இதுதான் சொல்ல வராங்க, இல்லை இதுதான் நான் அண்டர்ஸ்டாண்ட் பண்ணிக்கிட்டேன் அப்படின்றதுல இட்ஸ் மோர் ஆஃப் யுவர் சென்சிங் அண்ட் த பர்செப்ஷன் பார்ட். ஹவு த யூ ஆர் கலெக்டிங் த டேட்டா and how you are processing it, how do you inference, are you taking the inference of it. The next one is you will carry on different tasks, you will do different tasks, even the locomotion and the manipulation. When you consider as a locomotion, we will be moved from one place to other. நம்ம இந்த இடத்துல இருந்து இன்னொரு இடத்துக்கு போறோம் அப்படின்னா we will start walking it. So we are using the legs, and if you want to do any kind of an activity using your hands, you will use some fingers, hands. It's a more of work collaboratively we are working on. It's a mere you will move and manipulate the objects. It's a very simple fundamental things what we will do. You can connect with any of these activities of yours. நம்ம பார்த்தீங்கன்னா மூவ் பண்ணாமல் ஒரே இடத்துல நம்ம உட்காருவோமா? முடியாது. ஈவன் கிளாஸ் ஹவர்ஸ்லேயே நம்ம ஃபுல்லாக உட்காந்துருக்கணும் அப்படின்றதே நம்மளுக்கு ஒரு டிஃபிகல்ட்டான ஆக்டிவிட்டி. அதே சமயத்தில் we are going to receive information. That's why we need to receive in some form or other. Another thing is we will do manipulation அப்படின்றது என்னன்னா some hands on activity. நம்ம லேத்தில் போய் நம்ம ஆப்ரேட் பண்ணுறோம். அப்போ டூல்ஸ் எப்படி ஹேண்டில் பண்ணுறோம், ஒர்க் பீஸ் எப்படி ஹேண்டில் பண்ணுறோம், மிஷின்ஸ் எப்படி ஹேண்டில் பண்ணுறோம், அதில் கூடிய ஸ்பேனர்ஸ், anything you use which requires some kind of a manipulation, grasping the object and placing it right way and using it appropriately, and you will be executing the task. Our tasks are different. Similarly, the robot task also different, but if a robot has a limitation, has a limited number of varieties of tasks to be executed compared to a human. So, however, some of the places we require repeated tasks, and the repeated task overcome பண்றதுக்கு we can use a robot. So it's a reprogrammable. that could be do a different task, but subject to your limitation. In later on, we are looking for the autonomous of handling it. In the sense, it's not so dependent on the human. Instead, it has to make its own decisions. Subject to where the authentication will be provided from a human end. How well it will be working autonomously and how well it will be interacting with the humans. That's what it's coming out is going to be Cobos. So it's a collaborative robot that will be interacting with the humans and does its activity. So as a robot is concerned, it's more or less imitates the human. So whatever the human does, we are going to use it on the a machine or a device. So we are providing sensing and perception abilities and ability for carrying out different tasks. And we are providing a capability for reprogramming it. And we are going to provide some kind of an intelligence to it so that it can work autonomously and also interacting with the humans without affecting the laws of our robotics. So it does not harm any one of them, any one of us, as well as it does not affect itself. ஸோ அதாவது அதையும் காப்பாற்றிக்கணும், மற்றவங்களையும் டிஸ்டர்ப் பண்ணக்கூடாது. அதன் மாதிரி இருக்கக்கூடிய ஒரு மிஷின் ஆர் இட்ஸ் கேன் பி மோர் ஆஃப் இன்டெலிஜென்ட் மிஷின் இஸ் குவாலிஃபைட் ஆஸ் அன் robot. So how this robotic structure will be looks like? I have provided a very what you call elementary level of structure, but it will be a predominant in most of the cases. You can see that there is an environmental sensor, something called motion planner. The other thing is controller. So this environmental sensor collects the data, it processes the information and gives to the controller, which will be operates the mechanical structure, like where the arm looks like this, and it will be within that there is a configuration sensor. Configuration sensor internal இருக்கக்கூடிய. So how the positions of the joints or the links are the any elements on the structure will be measured and it will be gives some feedback. இது வந்து கிட்டத்தட்ட ஒரு feedback sensor மாதிரி. That will be gives to a controller so that it does the respective control elements will be provided to the mechanical structure. Okay, the mechanical structure is the manipulator. So it will be more of our motors will be there, so which requires a control signals from the controller that will be operating the physical structure. So our more focus will be more focus will be on mechanical structure, and that too in this course we are looking at our modeling, and also it's a limited degree of freedom. That's a course structure has been the structure of this course has been presented. So when you are considering the mechanical structure, we may have an kinematic models, dynamics model. I hope that you have undergone some kind of course kinematics of machinery, டைனமிக்ஸ் ஒரு சில கோர்சஸ் நாங்கள் பண்ணியிருக்கோம். ஸோ அங்கே என்னெல்லாம் படித்தோமோ இங்கே வந்து இம்ப்ளிமெண்டேஷனுக்கும் வரப்போம். ஸோ வாட் எவர் வி ஆர் ஸ்டடி ஏர்லியர் ஆன் த செமஸ்டர்ஸ், kinematics படிச்சிருக்கோம், we have done some kind of velocity diagrams, so much of things we have done. We will be using the same concept but putting into a different arrangement. When you are comparing the mechanism, whatever you have seen in your kinematics previous semester, it will be a closed loop system. When you're considering this robot is concerned, it's an open loop system. That's all. Nothing more than that. This also does a similar way. It has a rigid structure, rigid links, and also the joints will be there. Based on the motions of the joints, the total system will operate. Like where you can relate to the four-bar mechanism. So that will be does four links இருக்கும், ஒன்று வந்து ஃபிக்ஸடாக இருக்கும், மற்ற மூணு மூவ் ஆகிட்டு இருக்கும். சப்ஜெக்ட் டு everything is connected by the respective joints. Revolute pair அப்படின்லாம் படிச்சிருக்கோம். So you can use a similar kind of approaches for here also. Apart from that, we supposed to have some kind of awareness on the actuator in terms of electrical, hydraulic, pneumatic. Recently, the artificial muscles also picking up. However, at least we need to understand what is an electrical, hydraulic, pneumatic actuators, how it works, ஈவன் நம்மளுடைய இதுலேயே ஹைட்ராலிக் நியூமேட்டிக் படிச்சுட்டு இருக்கோம். ஒரு automation, low cost automation வர்றப்ப we will be using this one. The second part will be of our computational network, or PC based or any controller based requirements. That how it works அப்படின்றத நம்ம தெரிஞ்சுக்கணும். ரெண்டாவது சென்சார்ஸ். என்னென்ன சென்சார்ஸ்? ஸோ there is a two sides of sensors. You can see that one is environmental sensor. It's an external one. Configuration sensor will be of internal one. வெரி சிம்பிள் திங் இஸ், இது ஒரு கேமரான்னு எடுத்துக்கிட்டோம்னா வெளியே இருக்கிறது என்னென்ன இருக்குன்றதை கண்டுபிடிச்சிடும். மெக்கானிக்கல் ஸ்ட்ரக்சருக்குள்ள பார்க்குறோன்னா நம்ம டிஸ்பிளேஸ்மெண்ட் அப்படின்னு சொல்லுவோம். ஒரு டிஸ்பிளேஸ்மெண்ட் மெஷர் பண்ணுறோம்னா என்ன சென்சார் யூஸ் பண்ணலாம். ஒரு ஆங்குலர் டிஸ்பிளேஸ்மெண்ட், ஏன்னா எல்லாமே ரோட்டரி ஜாயின்ஸ் சொல்லுவோம். ஸோ வென் யூஆர் யூசிங் அ ரோட்டரி ஜாயின்ஸ் வி மே மெஷரிங் த ஆங்குலர் டிஸ்பிளேஸ்மெண்ட். ஸோ ஹவு த ஆங்குலர் டிஸ்பிளேஸ்மெண்ட் could be measured and how be used for controlling the required actuation அப்படின்றது தான் டோட்டல் அரேஞ்ச்மெண்ட். இன்னொரு ஆஸ்பெக்ட்ல பார்த்தோம்னா இதோட ஸ்ட்ரக்சர் வந்து ஒரு கண்ட்ரோல் சிஸ்டம் அப்படின்னு சொல்லுவாங்க டோட்டலா. ஸோ த ஸ்ட்ரக்சர், த பிசிக்கல் ஸ்ட்ரக்சர் we have an inherent internal sensors, a control mechanism will does its work, the corrective action between the required and the existing. So the corrective action will be done and will be executes the required portion. ஸோ இதெல்லாம் எக்ஸிக்யூட் பண்ணணும்னா எல்லாமே என்னோட வயர்டு கனெக்ஷனில் இருக்கணும். ஸோ விச் ரெக்வயர்ஸ் எ கம்யூனிகேஷன் and it's supposed to have an interaction with a human, so which requires user interface. Everything requires power. So how the power conversion unit will work on. As a holistically, it's a total a system approach where the mechanical structure is one of the component where it does its a major task will be executed on the manufacturing industry. But it needs to be controlled by means of an actuators, controllers, the sensors. And there should be, of course, planners may be required how to execute this task. So everything supposed to be on a collaboratively or on a coordinated fashion. It's supposed to deliver its functionality. Okay. I will have a small stop. I will pass here. If you have any questions on the chat box, I will respond. Is there any disadvantage of robotics? Okay, I will address it. I have found out how many robots have a self-defeating parts. Okay. That's a very huge question to be answered. Anyway, on the end of this session or end of this course, please retain this question. I will also retain this question. You know, what are the biggest problems in robotics? Oh, okay. It's a very vast question, but it is very important also. As far as the problems exist in the robotics, we have our own work to be done. So the problems will be of where it starts with the manufacturing of these components to be assembly of it and also executing it is going to be the major challenges. Fine. We have been aware that what is a holistic structure and what are the why the robo is required and how this robo has been started with and how it has been start progressing, and we have been given in terms of the skeletally what is a requirement is all about. So the next part, as already discussed, however, now to ensure in terms of the industrial perspective, any industry is looking for the quality products and with a more efficient manner without harming or without any adverse effect, with a minimum time and minimum cost. So in order to have a better benefit out of it, there needs to be a better productivity. So much of our requirements for industry is concerned. That's one thing is it has to increase the product quality in terms of improving the accuracies and their repeatabilities, so that the quality of their products will be saleable at the market and has a better rapport on the or the branding of the product. And the second one is how effectively they will be improving the efficiency so that their workers or the employee will be comfortable and try to undergo any dynamic situation. and that should be of a very safety environment and environmentally viable one. And we need to reduce the cost of it by reducing the wastages in terms of the scrap and reducing our in-process inventory and reducing the labor cost. The very important thing is critical factor is reducing the manufacturing lead time. So when you're considering the lead time, it's a total time required to process or execute, developing or creating a product. While doing it, we are not spending a time for value addition. We are spending non-productive time also. So how effectively we need to reduce the non-productive time? That's a very critical part where the robot will be the one of the solutions for reducing the non-productive time, executing that activity in a quicker as well as in precise manner. So the robots will be deployed most of the manufacturing industries, and that will makes us to improve their productivity. So automatically the value for doing will be improved upon. So that's why we are more focusing towards our industrial robot. And also we are looking for the replacement of repetitive, ergonomically difficult and physically demanding and sometimes dangerous work needs to be replaced. So wherever the humans are undergoing an fatigue in nature, we can deploy a robot, which is a machine, which works for a 24/7 on requirement, but the human cannot do because they have their own fatigue and the physical conditions. So the robots are preferred wherever the dangerous, dirty, and dull and difficult environments will be helpful for the humans in terms of for automation purposes or supporting in terms of the assistance or augmentation, or it could touch it autonomously also. So sometimes some of the industry could be of not need of a human intervention for what you call night shifts. All the machines will take care of themselves and work on. So whenever we require, we will be on the regular routine time and we will be taking care of it. So we like to perform a 4A, 4A in the sense automation, augmentation, assistance, and autonomous tasks in an 4D environment. It's said if you are dangerous, dirty, dull, and difficult. To have a replacement as well as the betterment of the human value as well as the human work, we'll be preferring the industrial robot. For example, assume that there is a painting section. So when you are deploying or employing a human worker on a painting shop, so it's going to be a very enclosed environment and it's subjected to they have been issues on the respiratory ailments maybe as a result of this kind of painting shops. So you can see that this is a small arrangement where there are 4 robots has been deployed and they have been enclosed. They are not breathing indirectly, but it does this required work in a much better form. So this is one of the arrangement where the car will be parked and the interior painting could be done as well as the outer also. So it's going to be a booth may be available for interior and the exterior, and the robot will be placed appropriately, does its work. So here the productivity will also improve, and also the human also valid more in this kind of categories. So certainly this kind of an environment prefer to have the industrial robot. Surely the quality also improves and the amount of paint spent on this process could also be reduced. Now to have okay, that's a part of why we are using an robot. Now we are going to set ourselves into a global environment and try to see that what is the statistics of it. So the International Federation of Robotics report of 2022, they will be collecting it at 21 and releasing it at 22 based on the nature of it, This is a growth of our installations in terms of thousands of units. You can see that there's a huge increase in particularly on the Asia and Australia regions because of the increase in their productivity as well as the manufacturing sector. And also it has been annually, it has been maintained more or less. This maybe the recession area and also the COVID period, we have been slightly lower down, but still it exists. Even this pandemic environment, the robots has been supporting us in terms of manufacturing and also whatever we require for supporting can be support has been extended by this kind of an automated industries. So this is a very simple arrangement. You can see that the consistency has been maintained in most of the European countries, and they because of this increase, they are also slightly increasing their abilities. Whereas in the America is concerned, already they are established some kind of things, but they are sustaining it. So this is an environment where the our we can place our India in this area. We have little bit enhanced, but compared to a China or other Germany or Korean, our usage of industrial robots will be minimum. But in future, as we are growing the country, we are looking for more efforts on the manufacturing. So when you are going for a high precision manufacturing, we are in need of the support from the industrial robots. Not only purchasing an industrial robot is not sufficient. We need to build the capacity building. You are the future engineers are going to handle these kind of robots on the new digital manufacturing environments. And the other part will be of which sector of the manufacturing will dominating. Here you can see that the electrical and electronics companies like your chipboard manufacturers or any process manufacturing, which requires very precise positioning and precise assembly of it, which requires a more dexterity and the fine motion, where the human skills are limited in nature, they will go forward industrial robots. The other segment is evergreen, is going to be an automotive sector, where they have started using the industrial robot because of their market demand and also the precision and the mass production requirement they are driving to do it. The next one is on the metal and machinery part, and there is a scope for the food industries, chemical industries, and others too. These are very authentic evidence. This is a report for 2022. Still, this can be a very huge scope for the improvement, and the installation is going to be improved a lot. Very quick glance of it. Whatever we have seen in the video, the same thing. 76% of the global installation of in countries. They are dominating on the manufacturing, particularly China, Japan, USA, and Korea and Germany. And the China, out of which it's kind of how the China is moving on. It's a 44% of total installation in 2020, but which is going to be a 58% more than that Europe and America has. So they are growing in a very accelerated manner, and they are targeting on the manufacturing hub, and they are building their capacity in terms of automation. However, we have our own challenges in terms of our 25% of our units in 2020. In the sense, we are slightly low in their installation during the pandemic period. However, the government has been taking up some effort and making toward new accelerated programs on robotics. I think you have heard about some kind of initiatives on the drones as well. So we are identifying some of the key areas, and we are going to equip ourselves towards it. So one of such programs could be of this online courses. It is not satisfies all the skill sets, but it provides you an awareness and a hands-on experience that makes us to move from this place to the next level. Very quick, important inferences. I have pointed out around 10 points here. Please listen carefully. That will be makes you to do. That will makes you to move here onwards. The automation is the driving the job creation. Okay, so automation is a key area is coming up. However, the human labor will remain competitive in the sense is based on the skill set what we have, not in the traditional way, but also we need to have a digital way of doing it. There is a new skill set is expected on the industries. If you are prepared for it, the human labor still competitive. And the most experts on the three industries covered in this report, in the sense this IFR report, is mostly on the manufacturing, logistics, and healthcare. So manufacturing is a major hub. Even the products produced for logistics and healthcare will be done at the manufacturing industries. So it's a very, very major domain in which we are looking for the automation as well as the precise, accurate parts. And we are going to start working along with the machines. Hereafter, there will not be any barrier between that. We will be start working along with these machines in the sense the robots. The automation can create a rewarding job profiles for the workers in terms of the automation will be reduces the fatigue work but improves our intellectual part. So there will be a more of a job satisfaction proportional to the salary is expected. The robots make work safer and less physically demanding. So some of the places, the safety of the human will be improved, and some kind of physical effort could also reduced. A shortage of qualified employees in holding back the growth. In the sense, we require a skill sets to take up this new growth, new evolution of it. So we are supposed to equip ourselves on this. I have highlighted this point in the sense the process expertise is as or more important than the pure IT skills in manufacturing and logistics. It's a wonderful news for the mechanical and the allied industries. This kind of an effort will make us to earn much better than an IT professionals. And also it can be a future requirement as well. We are supposed to have both the uh, um, technical skill in terms of the mechanical as well as some kind of labor on the automation side. In terms of programming, slight electrical aspect, expertise more sufficient for making us to a better career opportunities. Experts call for the title collaboration with an industry, government, and the educational institution because it can be a very huge, drastic growth is happening, which may require all the persons in the industry, government, and education institution has been collaboratively work together to reach out this one. One such effort could be of this course itself. That's what the governments will need to develop a policy incentives to encourage the corporate investments in training and or set up their funding for education. So it's a one of the training institute of Skillsonics could be of one of the person will be taking this robotic initiative, and they are making this happen. So it's a more of a collaborative effort is expected that makes us to drive to the new beginning. Very simple thing is we are looking for the betterment of the manufacturing scenario in terms of efficiency. Starts from the raw material to our packing, where the objects has to be handled at all the places. And we can work the robot can be worked for 24/7 for continuous production, so that productivity could be improved upon. And the equipment will be of a highly flexible in terms of what are the functions we need to do an appropriate programming may be required. The manufacturers start preferring the robots because there is a lack of skilled labors now. At the same time, the market demands more precise, high quality products. On the competitiveness, they need to go for this kind of an extension activities like our automation and using of our robots. Sometimes offer massive production, the cost effectiveness is also one of the criteria for any market requirement. So how well we are going to use these robots in a different format, and new innovations or improvements are expected out of you for a small scale industries to a large scale industry. That will be one of the reasons we are here. So already we have touched upon these areas. We are focusing. Very simple thing is how well we are going to effectively use the human value, and how effectively we will extract the work from the machines, so that the cost effectiveness, safety, stability will be improved upon. So when you're talking in terms of our manufacturing, we have a wide variety of manufacturing processes are involved, and most of the processes can be used for using robots, subject to how well it would be used on, based on the demand, based on the complexity of it. We need to devise appropriate programming or the planning of it, whether we are going for a robot or can we do for a manual. It's a more of a decision making, which requires a systematic investigation, and systematic study may be required. So for which we cannot directly deploy the robot. Instead, we will be seeing that how well it will be if it is deployed. So that's why we are more focusing towards our simulation part, where we can visualize all the working of it using your virtual environment. Is a use of our simple CAD packages or any robot-based packages, and we can see that how it works. Upon the satisfaction, upon the performance of it, we can start deploying it, and the deployment phase also will be reduced because of the simulation. So that's why this course has been more focused on robotic simulation for manufacturing. So our intention is more of our simulation part. That too is a simplified version of our robots. However, that could be extended for our complex robots as well. So we have an previously I was shown in that of the metal removal, metal handling, welding part. Here the assembly part. Can say that how well in the automobile environment, there is a huge lineup of our robots. This all the robots needs to be maintained, programmed. They are need to be coordinated so that the total flow is supposed to be more effective. So we have a wonderful opportunity for us to equip ourselves to have an exposed to this environment. Either if we are automating it, or you can be using a robot for any of this application. It's assembly, or maybe a packing, or maybe of a paint spraying. So it could be devised for different aspect of it. As one of the questions has been asked, what are the limitations of using the robots? Surely there's a chances of increase in your unemployment rate of existing skill set, but there is a wider opening for your new skill set. So we need to equip ourselves for our new requirement. This is a more dynamic environment. So how well we are going to adapt to this dynamic requirements. The cost of robotic automation may be difficult for an MSME. The small scale companies cannot afford in terms of the financial budget, and there will be a regular maintenance will be there. If it is going to be improper planning of the robot, that's a huge increase in your expenses. So there is a very wider scope for our planning and the simulation, and followed by the execution. So that requires some kind of a skill set in terms of planning and the simulation part. Humans execute the task with creativity, decision making, adaptation, and job learning. In the sense, human has a better learning ability, better respond to that dynamic environment. Whereas the robot is concerned, it has been limited to that programmed level alone, where always the human will be dominating the robot. That's no doubt on it. However, the robots needs to be deployed wherever we require, where our comfort instead of comfort, we'll say that our value will be keeps on improving on. Employees dealing with the robots require a proper training, which is an additional cost of the company. Surely, when you're moving to the new transition or new development, we require some kind of skilling required. Skilling requires a training part, and that is also a small cost involved for the manufacturers. However, there's a need of the hour. We need to go for the changes, adapting to the changes for the new beginning. So I have made an already. There's a robot is limited in the task execution. So there will be a different variety of robots may be required for doing some set of activities or the task where the human can be and wide flexibility is available. However, subject to work, the skill set that is available with the human. So human will be often more variable in the sense variable skill set and competencies available, whereas a robot will be in a structure, defined competencies, how effectively you are going to utilize this one. That's a question on our side. So normally a human will be using this component and placing it on the CNC machine. It's a normal environment. Whereas instead of that, there is a robot will be there, but it requires some kind of an additional things like what change in the tooling part. You may require as a safety enclosures, part feeding mechanisms, like what total automation is considered. So you need to have a part feeding mechanisms, some sensors, and how well it is be integrated. That makes sense. The production time will be reduced so that the rate of production increases in a better form. Hands-on device where you can operate. It's like you are considered as kind of your joystick for this robot. So on operating the respective buttons, it will be start moving on. Or joystick learning up arrow, down arrow, left arrow. So quickly wrapping up whatever we have done, we are start moving to that exact robotics way of learning. So which requires a little bit terminologies we need to work on and try to have it. First thing is robotics is a science and practice of designing, manufacturing, and applying the robots. So how well the robots will be designed, it can be manufactured, and how it could be operated. That needs to be done. The next one is on the manipulator part. It's a machine which consists of a sequence of joints. It's a links as well as joints, which will be moving, grasping the objects and moving it. And we are looking for the autonomy. What's the level of our autonomy we are going to have? And how well the intervention of the human will be reduced. The next one is on the physical alteration. So the robot will have an end effectors, which requires a change of tools. Suppose if you are looking for the pick and place to our welding, so we need to change the gripper instead of a finger gripper to a welding torch. So the full physical alteration may be required with an end effector part. It's a reprogrammable, yes, in the sense without changing a physical alteration, we will change the execution mode. That's called reprogrammable. Multipurpose, by changing the physical alteration, we will be end up with a different task. That's a multipurpose means. As a whole, the industrial robot is automatically controlled, reprogrammable, multipurpose manipulator, programmable in 3 or more accesses, or mobile for the industrial applications. Sometimes there will be devices, we will say that robotic devices. It will be more or less is a mechanism. It will be meet some of the characteristics of the industrial robot, but lacking there the number of a reprogrammable. The ability of a programmable and autonomy will be affected. Then we will say that's a robotic device. The next one is industrial robot system. Previously, we are considering only the robot. The robot will be start interacting with an other objects like your machinery, equipment, devices, any auxiliary part of it. It will be interacting for executing the task. As a whole, if you are considering it, it's called industrial robot system. Okay. The next one is industrial robot cell. In the sense, we are not considering the only single robot. We may consider a multiple robots. They'll be coordinately working on a single part, or it could be done at work different robots in a different machinery. It's considered to be a composed cell. Okay. The other technology is coming up is going to be collaborative robo. This robot designed for direct interaction with a human. In the sense, together as an robot as well as a human work together to execute the task. That's considered to be a collaborative robot. In future, it's going to be a normal in future. Thank you.